Now, the T, we know we assign a T itself equals 1. And the electric charge is defined as T divided by 3. So we have 1 divided by 3. And as we can see in this example, that gives us 1/3 for the electric charge of this generic Rishon, this T. We can see here, well, actually, I have to change the electric charge. We have the electric charge here now. The electric charge is 1/3 displayed above the T Rishon, because T divided by 1 divided by 3 is 1/3. Down here, the T for the V generic Rishon was assigned 0. And so we have 0 divided by 3, which gives us 0 for the electric charge on the generic V. And so from these generic T's and V's, we are composing what we would term generic quarks and generic leptons. And so, in a generic group, we have a T, a V, and a T, and that will compose a U quark. We can say we have a 2/3 charge, which is indicated by the standard model. Now, another configuration is the V, the T, and the V. We have 2 V's and only 1 T, so the electric charge here will be, and this is an anti-T, so the electric charge is minus 1/3, as it's supposed to be on the D quark. But again, we call these generic quarks. They're not the actual quarks that we will see built from these that compose the 3 generations. And here we have lepton groups. And here we have 3 anti-T Rishons, each having a 1/3 charge, giving us a charge of 1, electric charge of 1 for the generic electron. And over here, we have 3 V's, each having a charge of 0. And so for the generic neutrino, giving us an electric charge of 0. And so we can see that for each of these Rishons, we have other quanta, the spin quanta. Each of the Rishons is given a quanta of 1 plus or minus 1/2. And we have the isotopic spin. The isotopic spin, which connects the doublets, and we can see in the case of the U quark, we have an isotopic spin of 1/6 plus 1/6 plus 1/6, which is plus 1/2. And then if we look at the D quark, we have isotopic spins of minus 1/6, minus 1/6, and minus 1/6, which gives us a minus 1/2 for the isotopic spin for that doublet, the U and D doublet. Down here, the doublet for the leptons, the electron, and the neutrino, we have a minus 1/2 on the generic electron, and on the generic neutrino, we have a plus 1/2. Now, of course, color is also displayed, and it's displayed for each of these according to the definition given in the standard model, where there are 3 values, including 0, plus and minus 0.1/2, that sum to 0, and the order of these, of course, determines the color of each of the Rishons, and then the sum of those will determine the color of the generic quark or the generic lepton. In addition, we have the weak charge, which is associated with the spin, in that only left-handed generic quarks should be carrying a weak charge. Now, this U quark had 2 minus 1/2 and a 1/2, so it has a left-handed or minus 1/2 spin. And we can see when we look at the charges for the weak charges, they will sum up to 1/3 plus 1/3 minus 1/6, which is plus 1/6 for the left-handed U quark, which is indicated by the standard model. And if we go over here, we have the D quark, and we see that the D quark also had a left-handed sum of spin. And we have minus 1/3 plus 1/6, which gives us minus 1/2 for the weak charge on the generic D quark. And these are the weak charges which are indicated by the standard model. And we can go here and look at the electron and see that this left-handed electron then has a minus 1/2 weak charge, and this actually right-handed neutrino, we'll look and see this is giving us a 0 for the weak charge. So let's make sure that it is displaying a right-handed spin. And we can see here we have 2 plus 1/2 and a minus 1/2, so this is a plus 1/2. So the correct weak charge is displayed. And over here we had a minus and a plus, making this a left-handed particle. So therefore it did exhibit a weak charge. And so we can see in this way, these groups of generic quarks and leptons, we can see made of the generic rishons, when we combine them with bosons composed of the flavored and prime rishons, we will see that we will be able to generate in compositions the 3 generations of particles indicated by the standard model.